how can we detect radioactivity? The particles that are given off are extremely small, right? The biggest one is a helium nucleus, right? So you can't see them or feel them, but we can detect these particles by looking at the interactions that they have with other atoms or molecules. So one method of detecting radioactivity is what's called a thermoluminescent dosimeter. And this is going to measure radiation exposure over a period of time. Dosimeter is basically measuring a dose, right? So this is a picture of one. So this is like a badge that someone who's working with radioactivity would wear to monitor how much radioactivity they're getting exposed to during the course of their job. So this will have salts, crystals of salts such as calcium fluoride. There are other ones as well. They get excited by ionizing radiation. Those excited electrons get trapped. There we go. The excited electrons get trapped in by intentional impurities that are put into the crystals. And then when you heat those crystals, they will luminesce, they will give off light in proportional to how much radiation it's been exposed to. So working with radiation, you may wear a badge like this, and then it will be swapped out for a new one occasionally, and they'll go and they'll heat this up and analyze it to see what your level of exposure was. Any questions? This is the one you're probably the most familiar with, a Geiger-Müller counter. This is the thing, the beep, 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 beep thing, the clicking that you see in movies and stuff. This measures radioactivity in real time. So the dosimeter, if you parachute into Chernobyl or something, it's not going to alert you that, hey, there's dangerous amounts of radiation around. It's not until later when you have that badge analyzed that they're going to say, hey, where the heck were you, right? But this is going to tell you in real time, am I getting close to something? You move back away, further away from it. So how does this work? The particles that are emitted are going to pass through an argon-filled chamber. So here we've got this chamber that's filled with argon. And as these radioactive particles pass through, they ionize argon atoms as they hit them. We've got a voltage, a high voltage that is applied across this. There's an anode and a cathode. And it can be rigged to produce an electrical signal that is either displayed on a meter or turned into an audible clicking noise. So this will detect when argon ions are formed. Argon ions are formed when they interact with radioactive particles. This is a little portable handheld one. Any questions? Yeah. Why did they use argon? That's a good question. It's a really good question. I can think of a couple possible reasons. Argon might be more easily ionized than some of the other noble gases. And it might also be just that it's easier to come by because there's actually argon in air, whereas the other noble gases, are just harder to get. You can't get them by concentrating air. That's a good question. Anybody else? Another type of detector is called a scintillation counter. Again, this also measures radioactivity in real time. Here we've got those radioactive particles going through a material such as sodium iodide or cesium iodide that will emit either UV or visible light when it gets excited by these energetic particles. So unlike that, the thermoluminescent badge, where what is produced by that is trapped and looked at later, here we're going to look at the amount of visible or UV light in real time. And again, the light gets detected and turned into an electrical signal that you can see on a meter. And exactly how that occurs, is actually quite complicated. It involves a lot of electronics and stuff. Any questions about detecting radioactivity?